Hey everyone, hope you're excited to be here tonight. I know I definitely am. It's great to meet you. My name is Tassine Daya. I'm a 17-year-old from Toronto, and I spent the last year working in blockchain and Web3, and now I'm looking into machine learning. I'm really excited to share a problem that really means a lot to me. Last year, I spent 2 months in Tanzania teaching English to a group of students, and I was using my laptop with resources like YouTube and Khan Academy that are pretty native to me. But after a few weeks of teaching, I realized that these kids were so astonished, not so much by my English knowledge and my skills, but more so by the world of information that I was showing them that they had never had access to before. And this was a pretty profound realization to me that we're trying to solve the world's biggest problems with technology, but none of these technologies can actually address these issues unless internet access is democratized and these technologies can be accessed. And upon further research, I found that this is not a small problem at all. And still today, over 37% of our population is offline. And when you think about why this is important today, the artificial intelligence market is projected to be hitting an inflection point and changing the lives of us here in North America. But when we see how this impacts the people in these developing countries, like the Middle East and Africa, you can see how the gap between the developed and the developed nations is only going to continue to grow. And these problems are actually going to be exacerbated unless we have a radical shift in this global internet access. So to understand this problem fundamentally, let's run through some technical concepts of how the internet works. The internet runs off of an algorithm called Border Gateway Protocol, which is essentially like the postman of the internet and decides where to send data packets, which are compilations of data across a network based on a variety of decisions. So for example, if you want to watch a YouTube video in whatever city you're in, this sends a request to a data center where this video is stored, and Border Gateway Protocol decides how to get this data from that center back to your computer. And there are a variety of pathways it can take, and this protocol decides on a variety of decisions, such as the cheapest pathway, the quickest, the least number of hops between systems, and a variety of other business decisions between each internet service provider of how it wants to transport data to you. And each of these decisions is called an attribute in the network. What I'm proposing is a way to apply an electricity smart grids framework to these internet algorithms. And the way that I'm applying this is through the idea of a demand forecasting model for what systems have certain demand at certain times. And just like how electricity smart grids manage their distribution and generation of electricity on the grid, these internet smart grids would decide where to route this data according to the systems with the least traffic. In this dynamic traffic shaping algorithm, the way it would work is a model would predict the path with the least traffic. The protocol would then route these data packets on those pathways accordingly, which would optimize the network for bandwidth and minimize latency without actually having to build more expensive infrastructure that is often very difficult to lobby for in regions with low population density. I built this model through data sets from the International Telecommunications Union, Kaggle, and Ericsson's website, and specifically looked at comparing the global internet bandwidth usage to the region I was looking at in East Africa. I started out by building this model through a gradient boosting algorithm called XGBoost because I did a comparison between the performance of the gradient boosting algorithm and profit algorithm, which is a time series algorithm from Meta, and found that when you're comparing the mean absolute percentage error, that the gradient boosting algorithm performs 6% better for the data set that I was using. So I decided to dive deeper into that algorithm. Specifically, I focused on the African subcontinent because in the rest of the world, this continent has the lowest bandwidth. And a direct reason for this is the fact that they're the slowest adopter of wireless technologies like 5G, which paves way for an opportunity for my project to optimize the existing infrastructure they have for cabled or fiber optic internet. But when you think of providing internet access to these developing nations, Starlink is one of the first solutions that pops up. But unfortunately, Starlink has many holes in it today that can get solved through the development of technology, but still will never be as reliable and efficient as fiber optic or cabled networks So in regions where it's possible, it's always optimal to go with the cabled or fiber optic networks. And knowing this, the company 2Africa has been funded by Meta and Google to literally build a ring of fiber optic networks around the continent of Africa that connects it to data centers in Asia, in Europe, and North America to provide broadband to the coastal and urban areas. And the gap that I want to fill and the issue that I want to optimize is in these lighter green areas where population density is much lower and limited infrastructure is going to cause problems with bandwidth. What makes this problem so hard is that when wanting to pilot this project, a lot of the connections I have and resources I have for understanding how to implement it are in North America. And as you may know well, the industry in North America is very oligopolistic, and that means that it's very difficult to adopt new technologies because it's slow-paced and very expensive to innovate. So I have a 3-step plan as to where I want to take this project next. It starts with figuring out how I can apply this demand prediction model, which is relatively theoretical, to building on top of simulation softwares and algorithms like BGPlay and Anycast to take steps towards implementation myself. It then involves getting more technical validation from researchers at the Institute of Electrical and Electronic Engineers, and finally, reapproaching the connections I have with executives at companies like Verizon's Innovation Lab and Ericsson to figure out what are the action items I can take to implement something like this, either in North America or in the target market at the end, which is East Africa. Because at the end of the day, I want this demand model not to just sit on my computer. I want it to change the lives of those students who lack this fundamental necessity. Thank you. And I'm happy to answer any questions.
Yeah, to see an awesome presentation. Had a quick question for you. So as you know, the global AI market has been projected to grow a lot, right? But everyone or a lot of people are focused on GPU and research and development and overlook the need to optimize these energy grids. What do you think that people aren't looking at this and are prioritizing working on GPUs and R&D over there instead? Is there a lack of incentives over there?
Yeah, that's a good question. I think that all 3 of those things, GPU, energy, and internet broadband being distributed, are key factors in allowing AI to change the developing world. But really, it comes down to how easy it is to innovate in the electricity and internet grid market, because GPUs is something that can be developed by startups. Changing the internet landscape is something that involves a lot more institutional priorities and something that is going to a lot longer term project, which is why you see a lot less innovation within the industry. It's a good question.
Where in a world that's shifting more towards products like Starlink and satellite connections and Lightspeed and other LEO fleets, where does this retain a unique competitive advantage?
Yeah, that's a good question. One that I researched a lot when figuring out specifically in the rural and isolated areas, because Starlink is a more scalable solution in that there's less physical infrastructure need to be built. But like I mentioned, in those areas with low population density that have existing infrastructure that needs to be optimized, it's most optimal to actually focus on optimizing the existing infrastructure rather than trying to expand a vast network of fiber optics or copper cables, because there is still opportunity to make the most of the existing money that's been spent for infrastructure.
All right, thank you.